I wanted to open the winter break homework with some concept questions, and I should say any question that's called a concept question in a physics class, I almost like from the perspective of a student answering the question, I would almost call them badly worded number questions. Of course, from a physics teacher perspective, these are a great way to delve deeper into how we think about physics, how we do physics. But to somebody who's new to them, they can seem a little disorienting. And so I want to go through a couple of tricks, techniques, tips that I can offer to make these questions a little bit more manageable. So, for example, question number one is to explain two ways a heavy truck and a person on a skateboard can have the same momentum. Well, before we try to dream up all kinds of scenarios involving heavy trucks and people on skateboards, let's just look at the momentum equation. So, there's two parts to it. Momentum is mass times velocity. So, for example, let's say we've got a heavy truck. Now, we're the ones who get to decide the mass of a heavy truck. So why don't we make the heavy truck 10,000 kilograms, let's say. And let's say our skateboarder is, let's make it a kid, like a really small kid. Let's make it a 10 kilogram kid, which I think is like 20 pounds. So I guess we're talking about a 2-year-old. That's fine. We're just trying to solve a problem here. We don't need it to be completely accurate. Now, what's two ways that these objects can have the same momentum? Well, maybe we could make the speed of the truck something really small, like 0.001 meters per second. So it's going slowly, like a millimeter a second. How would a kid on a skateboard have the same momentum? Well, same literally means equal. So why don't I take this 10,000 kilogram truck, times it by that speed, that velocity to get me the momentum, and then let me take this 10 kilogram kid and figure out what speed that kid would need to go at. And so when we solve for v, we will end up getting 1 meter per second for the person. So we'll just go with one way. I'm going to let you come up with a second way, maybe in class as a warm-up. Now, number two, in stopping an object, how does the time of impact affect the magnitude of the force? This goes back to our egg drop experiment. So a longer time allows us a smaller force. That was the point of the landing pad. And a shorter time actually means we have to deal with a larger force. Okay, now, the relationship between an impulse and an object and the change in that momentum, well, impulse causes the change. So impulse actually equals the change in momentum. So number-wise, in problems, they're the same. Another way to think of it is that impulse is the cause and change in momentum is the effect. Now, for constant force, the time the force is applied to an object doubles, the impulse will, in fact, double. But let's not guess that. We know that impulse is F times t, right? Let's make up some numbers. Suppose I have 100 newtons of force that I apply for 1 second. That would give me 100 newton seconds of momentum. Now, let's double the force. So 200 newtons of force applied for 1 second gives me 200 newton seconds. So yes, indeed, it does double. And for question number 4, since impulse equals the change in momentum, if the impulse is doubled, then the momentum change is also doubled. So that is page 1 of the winter break homework, and I will upload videos for the rest of the pages in a few minutes.